Okay, today's lesson will be on evaluating quadratic functions and also how to multiply polynomial expressions and functions. So let's go ahead and get started on evaluating quadratic functions. So evaluating quadratic functions. Here's an example. We are given f of x is equal to negative 2x squared plus 5x minus 1. Let's go ahead and evaluate the quadratic function at 4. So the first example we're going to be looking at is f of 4. So what does that mean? It does not say f times 4. It's in function notation, and again, that's f of 4. So we're going to evaluate the function f at the value of 4. So here's our function f. We're going to plug in 4 in for x and evaluate it. What does it become? So negative 2 times 4 squared plus 5 times 4 minus 1. The squared only applies to the 4. This becomes negative 2. 4 squared is 16. So again, 4 squared is 4 times 4. Plus 5 times 4 is 20. Minus 1. Negative 2 times 16. We have negative 32 plus 20 minus 1. Negative 32 plus 20. Negative 12 minus 1. And negative 12 minus 1, when you are subtracting, we have negative 12 minus 1, you do change. So it's going to be plus a negative. So negative 12 minus 1 is the same thing as negative 12 plus negative 1, which gives you negative 13. So f of 4 is equal to negative 13. Again, that's saying the function evaluated at the value of 4 is equal to negative 13. Let's look at another example. We have f of negative 3. So again, we're going to go ahead and evaluate the function f at the value of negative 3. So we're going to plug in negative 3 in for x. So we have negative 2 times negative 3 squared plus 5 times negative 3 minus 1. Again, the squaring only applies to the negative 3. So we have negative 2. Negative 3 times negative 3 is positive 9. So negative 2 times positive 9. And then we have 5 times negative 3 is negative 15, so minus 15 minus 1. So now we have negative 18 minus 15 minus 1, because negative 2 times 9 is negative 18. So again, negative 18 minus 15, adding a negative, same thing as adding a negative. So negative 18 minus 15, or plus negative 15, is negative 33 minus 1. And again, same thing. So you can add negative 1. And then negative 33 plus negative 1 is negative 34. Okay. So the function evaluated at the value of negative 3 is negative 34. All right, let's go ahead and look at one more. Let's look at f of 0. F of 0. So again, evaluating the function f at the value of 0. So we're going to plug in 0 in for x and evaluate the function. So we have negative 2 times 0 squared plus 5 times 0 minus 1. 0 squared, so 0 times 0 is still 0. So it's negative 2 times 0 plus 5 times 0. 5 times 0 is 0. Minus 1. Negative 2 times 0 is also 0. And then 0 plus 0 minus 1. Bring everything down. 0 plus 0 is still 0, so 0 minus 1 is negative 1. So f of 0 is negative 1. So again, all of these are the same type of problems where you plug in the given number in for x. Again, this is function notation, so you're evaluating the function at the given value inside of the parentheses. If the number was on the outside of the parentheses in front of the f, that's when you multiply the entire function by that number. But because the number that we're given is inside of the parentheses, you evaluate the function at that given value. All right, so that is how to evaluate quadratic functions. Let's go ahead and let's also evaluate another quadratic function in the form of a graph. So this is through equations. If they give you a quadratic function, and it's quadratic because the highest degree is a 2, so the highest variable here, so x squared, so the highest coefficient is 2, and so therefore it's going to be a quadratic function. So let's go ahead and look at a quadratic function in a graph form and see how to evaluate those functions when it's given to you in the form of a graph. So instead of equations, we're going to be looking at graphs now. So say if you're given a graph of a quadratic, okay, so say if we're given this quadratic. Here's the graph. That should be here. Okay. So we have a few points. Let's go ahead and look at the points. We have 2, 5. We have 4, 3. And we also have 6, negative 3. So this is a quadratic when it's graphed. So anything in the form ax squared plus bx plus c is going to give you a parabola. So y equals mx plus b gives you a line. That's the standard form of a line. Y equals ax squared plus bx plus c, the standard form, and it gives you a parabola, either facing downwards or upwards. In this case, it's facing downwards. But let's go ahead and see how to evaluate the quadratic function. So if we wanted to figure out f of 4, again, this is function notation. So this is saying evaluate the function at the given value of 4. So your input value is 4. So what is the value of the function when x equals 4? So again, remember the function as, like, you can think of it as a machine, and you input certain values and you get out certain values. So there's an input and an output. So you input the number 4, what is your output? Again, in this class we're looking at input values primarily being associated with your x values, and then the output values are going to be associated with your y values. So if you're inputting the number 4, that means x is going to be 4. So when you input x of 4, what is our y value when x is 4? Well, here we go. X in this case is 4. Our y value is 3. So the value of our function, evaluated at the value of 4, is equal to 3. So x is 4, y is 3. So again, function notation, f of x is the same thing as y, and so y is equal to the value of 3. Another one. We want to find x, so f of x equals negative 3. So let's see. You need this point over here. This is going to be -2, -3. So let's see, what am I trying to say? F of x is equal to -3. So your y value is -3. What values of x give you -3 for y? So when y is -3, what are the values of x? So your output is -3. What are your inputs? Like what can you put into your function in order to get an output of -3? So again, thinking of this as our y is equal to -3. Well, y here is -3 and our x value is 6. And similarly over here, y value is -3 and our x value is -2. So x can either be -2 or +6. So x can be either -2 or +6 in order to get a y value of -3. So again, this is saying what is your function, what is the value of x when y is equal to -3? So again, this part is just being familiar with function notation and understanding what it's asking you. So let's look at another one. F of x is equal to 5. Okay, so this is saying when y equals 5, what is your x value? My screen keeps going dark. Sorry, I have to keep moving my mouse. Okay, so f of x equals 5. So y equals 5. What are the x values when y equals 5? Well, there's actually only one point where y equals 5, and that's where x equals 2. So x equals 2. Let's look at another example. F of x equals 6. So what is the value of x when y equals 6? Well, as we can see, our parabola is facing downwards. So the highest y value that we're ever going to have is at 5. This is 5. Our graph doesn't go up. It goes down. So it's all values less than 5. So therefore, this is saying when y equals 6, what is the x value? Well, y will never have a y value of 6 because, again, our graph only goes down. It's from 5 and below. So because of that, there's no solution. Like nothing. X will never equal anything to get y equals 6 in this particular graph. Let's actually do the reverse. So let's do one more example. Can you guys see down that far? Yes. Okay. So f of 2 equals what? F of 2, again, your function evaluated at the x value of 2. So we go to x equals 2, y is equal to 5. So you can see the difference between numbers 3 and number 5. Because here, f of x equals 5. That's saying your y value is equal to 5. What is x? So y value is 5. X is at 2. Here, your function evaluated at the value of 2. What is the y value when x is 2? So x is 2, y is 5. So it's going backwards. So there's a difference between where, again, the x is and what you're trying to solve for. So again, just being comfortable with function notation is going to get you through this section. Okay, so that is how we evaluate quadratic functions in the form of equations and also in the form of graphs. So let's go ahead and take a look now at multiplying polynomial expressions and functions. So how do we multiply polynomial expressions and functions? So multiplying polynomial expressions and functions. All right, let's go ahead and, well, how do we do it? We always use the distributive method. That's all you have to do. So when you're multiplying two polynomials together, you're going to use the distributive method. Now let's go ahead and look at an example. So we have 5x to the third times 3x squared minus 4x plus 2. So 5x to the third times 3x squared minus 4x plus 2. So again, we're going to use the distributive method. So how do we do that? Well, we're going to take our first polynomial expression and distribute each of the terms, in our first polynomial. In our first polynomial, we only have one term. So we have 5x to the third. So we're going to take 5x to the third, and we're going to distribute it to every term in our second polynomial. So we're going to take 5x to the third and multiply it out. So for the first term, let's see, 5 times 3 gives you 15. X to the third times x squared. You add the exponents. So 3 plus 2 is 5. So x to the fifth. Moving on to the next guy. 5x to the third minus 4x. 5 times minus 4 minus 20. X to the third times x. Again, there's an imaginary 1, or an implied 1. And so 3 plus 1 is 4. So we get x to the fourth. And then 5x to the third times 2. 5 times 2 is 10. And then we just have x to the third. So that's how you multiply polynomial expressions with each other. Let's look at another example. Let's take 4x minus 1 times x plus 3. Okay, same concept. So just because there are two terms in that first polynomial, it doesn't matter. You're still going to distribute them. So what you do is you take one at a time, distribute it, and then you take the next one, and you distribute it as well. So the first term is 4x. So let's go ahead and take our 4x and distribute it to every term in our second polynomial. So 4x, we're going to distribute that to the x and also to the 3. So 4x times x is 4x squared, because again, you're adding the exponents. So 1 plus 1 equals 2. And then 4x times 3, 4 times 3 is 12. We get 12x. Then we're going to take our second term, this negative 1, and we're going to distribute that to every term in our second polynomial. So negative 1, distribute that to both terms. Negative 1 times x is minus x. Negative 1 times 3 is minus 3. And then from here, we're going to go ahead and combine like terms. The only like terms we have is 12x minus x. 12x minus 1x gives you 11x. So we have 4x squared plus 11x minus 3. So again, just because it has two terms, that doesn't matter. You just take each term individually and distribute it to every term in your second polynomial. All right, let's look at another example. I'm going to need more room, so I'm going to go ahead and erase the top one. Let's see. Nope, I'm going to have to erase this other one too. Okay, but hopefully everybody has it down. Okay, so let's go ahead and take a look at this next example. We have 2x plus y times 5x squared minus 3xy plus 4y squared. Okay, So even though the polynomials expand and are growing bigger in the number of terms that they have, it doesn't matter. It's the same concept. So again, our first polynomial has two terms, so we're going to take each individual term and distribute it to every single term in our second polynomial. So let's go ahead and take our first term of 2x and go ahead and distribute it to every term in that second polynomial. So we're going to apply it to the 5x squared, to the minus 3xy, and also to the 4y squared. So 2x times 5x squared, 2 times 5 is 10. X times x squared, we have x to the third. 2x times negative 3xy, so 2 times minus 3, we have minus 6. X times x is x squared, because 1 plus 1 is 2, and then y. Plus 2 times 4 is 8, and then x, y squared. So that's from distributing our 2x. Now we're going to take our y and distribute that to every term in our second polynomial. So taking the y and distributing it, we have y times 5x squared. So plus 5x squared y. Y times minus 3xy is going to be a minus 3xy squared. Again, y to the first power times y to the first power. 1 plus 1 is 2. Taking that y, distributing it to the 4y squared, plus 4y to the third, because 1 plus 2 equals 3. And now we're going to go ahead and combine like terms. So what are some things that are similar? Okay, there's only one 10x to the third. Okay, took care of that guy. Let's go ahead and combine other stuff. So negative 6x squared y. So we need to find another term with the x squared y. So again, we can only combine like terms. So the x squared y, there has to be another x squared y. This is xy squared. That's not a match. X squared y, that guy's a match. Xy squared, not a match. Y to the third, not a match. So negative 6 x squared y plus 5 x squared y. Negative 6 plus 5 is minus 1. So we have minus 1. But you don't have to write it. X squared y. You can write it if you want to. You can do a minus 1. X squared y. Okay, that takes care of those two. And then now we're moving on to 8xy squared. So we need another xy squared term. So 8xy squared minus 3xy squared, those both have in common the xy squareds. And this has a y cubed, so not a match. So then we have 8 minus 3 is 5. So plus 5xy squared plus 4y to the third. That's the only term that's left. And that's it. So we have 10x to the third minus x squared y plus 5xy squared plus 4y to the third. All right, let's go ahead and look at another example. We have 3x minus 2 squared. Okay, so I know a lot of students like to distribute this 2 and apply it to the 3x and apply it to the 2, and they get 9x squared minus 4 or 9x squared plus 4, some variation of that. That's wrong, because what this is saying is it's a binomial, so it's 2 terms. So you have to expand it, because if you just distribute the 2 here, it's not correct. That's not how you multiply. That's not how you multiply binomials. That's just, you don't do that because of the fact that you lose some of the terms when you just distribute. Let me show you what I mean. So 3x minus 2 squared. That's saying, so squaring, the squaring concept is taking the value and multiplying it by itself 2 times. So 3x minus 2 is 3x minus 2 times 3x minus 2. And again, we're going to take, so we have just a polynomial times a polynomial, so we're going to take our first term and distribute it to every term in our second polynomial. So we're going to take our 3x and distribute it to both terms. So 3x times 3x, that gives you 9x squared. 3x times minus 2 is minus 6x. Then we'll take that minus 2 and we'll distribute it to both terms in the second polynomial. So negative 2 times 3x is minus 6x. Negative 2 times negative 2 plus 4. Okay, now go ahead and combine like terms. So we have minus 6x and minus 6x, but hold up. Let's go ahead and go from left to right. So we have 9x squared. That takes care of that first term. Minus 6x, minus 6x. So those two are like terms. We can go ahead and combine them. Negative 6x minus 6x is negative 12x, or minus 12x. That takes care of those two. And then plus 4. So 9x squared minus 12x plus 4. So as you can see, that answer is different than just getting 9x squared, either minus 4 or 9x squared plus 4. You lose out on that minus 12x, so which makes your whole answer wrong. So make sure that you expand this and you distribute in order to multiply. All right, let's look at another example. So let's look at 3p minus 8q. Times 3p plus 8q. Okay, so let's go ahead and, again, we have a binomial times a binomial. So why do I keep saying binomial? That just means a two-term polynomial. So again, we just have a polynomial, specifically a binomial, times another polynomial, and again, specifically another binomial. So whatever you want to call it, we have these things multiplied together. Take your first term, 3p, and go ahead and distribute it to both of the terms in the second polynomial. So 3p times 3p gives you 9p squared. 3p times 8q, 3 times 8 is 24pq. And then same thing, we're going to take that negative 8q and distribute that to both terms as well. So negative 8q times 3p is minus 24pq. And then negative 8 times q times positive 8q is negative 64q squared. Going ahead and combining like terms, we have 9p squared, because it's only p squared up there. Then we have 24pq minus 24pq. Those are like terms because they both have the pq. But 24 minus 24 is 0, so we have no more pq's. And then we have minus 64q squared. Whoa. All right. So that is how to multiply two polynomials together. Again, you just take each of the terms and distribute it to every polynomial, or every term in your second polynomial. So now let's go ahead and take a look at functions and, functions. Let's go ahead and take a look at those. So we'll look at functions, multiplying two functions, and then also composite functions, and we'll look at the difference between the two. So let's go ahead and give you two functions. We have f of x is equal to 3x plus 7, and then we have g of x, which is equal to 5x minus 2. So we have f of x, which is equal to 3x plus 7, and g of x, which is equal to 5x minus 2. let's go ahead and look at f times g of x. F times g of x. So f times g of x, what is that saying? So again, it's you're taking f of x times g of x. So remember what this means. This means, because it's a closed circle, it's multiplication. So f of x times g of x. So f of x times g of x. Let's take our two functions. So what is f of x? What is g of x? F of x is equal to 3x plus 7, and g of x is equal to 5x minus 2. So it's saying take your function, put it here, take the g function, what it is, put it here, and multiply the two quantities together. So this equals 3x plus 7, because that is what f of x equals. Oh, there we go. So we're taking f of x times g of x. So f of x is 3x plus 7 times g of x, which is 5x minus 2. And there we go. We have the same thing that we were just doing in the prior 5 examples. So we're going to go ahead and take that 3x, distribute it to every term. So 3x, distribute it to the 5x, and also to the minus 2. So 3 times 5 is 15. And then x times x is x squared. 3x times minus 2 is minus 6x. And then we'll take our, what's the next term? 7. So our next term is 7. We'll go ahead and distribute that to each term in our second polynomial. So 7 times 5 is 35. So we have plus 35x. 7 times minus 2, minus 14. Now we'll go ahead and combine like terms. So we only have one x squared up there. So we have 15x squared. We only have one x squared term, and that's the 15x squared. So we can't combine that with anything. Then we have negative 6x plus 35. So 35 minus 6 plus 29x. So again, these two are like terms because of the fact that they both have x's. So negative 6 plus 35, or 35 minus 6, gives you 29. And then we have minus 14. So it's our only term without any variables. And that's it. That's how to combine them. Okay? Next up, we have f times g of 2. Okay, so what is this saying? This is not saying 2 times, this function, the multiplication of f and g. This is not saying that. That's saying f times g of 2. So f of 2 times g of 2. So you're evaluating each function at the value of 2 and multiplying those quantities together. So this is saying f of 2 times g of 2. So we're going to evaluate the function f at the value of 2, whatever that number is, multiply that by the function g evaluated at the value of 2, whatever that value is. So we get one number times another number, which gives you the product. Let's go ahead and find out what those numbers are. So f of 2 means you're plugging in 2 into your function f. Here's our f function. We're going to plug in 2 in for x. So what is the y value of your function f when x is equal to 2? So again, this is function notation. We're going to plug in 2 into our function and see what it equals. So 3 times 2 plus 7. So again, we're plugging in 2 into our f function. So 3 times 2 is 6. 6 plus 7, and 6 plus 7 is 13. Okay, that multiplied by g of 2. So now we're plugging in 2 into our g function. 2 into g of x is equal to 5x minus 2. So we're going to go ahead and plug in 2 in for x into our g function and evaluate the function when x equals 2. So we have 5 times 2 minus 2. 5 times 2 is 10, 5 times 2 is 10. 10 minus 2 is 8. And then 13 times 8, you get 104. So you get 104. So 13 times 8 is 104. So again here, we evaluated each function at the value of 2, got those two quantities, 13 for f, 8 for g, multiplied those two quantities together and got 104. Okay, let's go ahead and look at another example. So let's go ahead and look at f of g of x. F of g of x. Okay, so again, that does not say fog. This is an open circle, which means it's a composite function. It does not mean, again, it does not mean fog. It means you're evaluating the function at g of x, the function f at g of x. So this is saying f of g of x. So we went over composite functions prior. And so f of g of x, evaluating the function f at the value of g of x. So g of x is 5x minus 2. So again, you work from the inside and work your way out. So g of x is equal to 5x minus 2, so we're going to plug that in here. So we're just going to replace it. So this equals f of, instead of g of x, I'm going to write 5x minus 2. Now this is saying evaluate the function f at the value 5x minus 2. So we're going to plug that into our variable space, into our f function. So we're going to plug in 5x minus 2 in for x. And it's kind of a weird concept to be plugging in, 5x minus 2 for x. Again, this is just like a dummy variable. It's just a placeholder. 3 times some value plus 7. What is that value that we're trying to plug in? 5x minus 2. So this is equal to 3 times the value that we're trying to evaluate it at. 3 times 5x minus 2. So 3 times 5x minus 2 plus 7. Okay, so now we're going to go ahead and take that 3, distribute it, and combine like terms. So 3 times 5x is 15x. 3 times negative 2 is negative 6 plus 7. 15x, that's the only term with x in it, so we can't combine it with anything. So 15x minus 6 plus 7, so 7 minus 6 is 1. So you get 15x plus 1. Okay, and then our last example is going to be f of g of 2. So f of g of 2. Again, it's an open circle, not a closed circle. So what I just had erased was f times g of 2. And that means you multiply the two quantities together. This is f of g of 2, so it's another composite function. So what is it saying? This is f of g of 2. So we looked at this prior. I forget if it was last week or maybe the week prior. But we have f of g of 2, so you have to evaluate g of 2 first. Get that number, whatever. So what is the value of g, of your g function, when x equals 2? Well, we have to plug in 2 up there, figure out what it is. Once we get that, then we'll have that number, and then we'll evaluate f at that value that we get. So this is saying g of 2 equals 5 times 2 minus 2. It's part of the equation. So this is saying g of 2, so evaluate the function g when x equals 2. Our g function is, g of x is equal to 5x minus 2, and so therefore we're going to plug in 2 into x over here. So then that's what we get, 5 times 2 minus 2. 5 times 2 is 10, and then 10 minus 2 is 8. Okay, so g of 2 equals 8. So instead of writing f of g of 2, excuse me, we can write f of 8 because g of 2 equals 8. So now we have f of 8. What is f of 8? I don't know. We have to plug it in. So what is the value of the function f at the x value of 8? Here's our function f. So what is equal when x equals 8? Let's go ahead and plug it in and find out. We have 3 times 8 plus 7. 3 times 8 is 24 plus 7, and then 24 plus 7 is 31. So ultimately f of g of 2 is equal to 31. So f of g of 2 equals 31. All right, that is it for multiplying polynomial expressions and functions. Thanks for watching.